So now we have seen how different kind of text pre-processing are being used and why it's important for doing the next stages of NLP modeling. So in this class, I'm going to give a demo on how to do some basic pre-processing techniques so that it can be utilized for the next few tasks. Let's start with sentence tokenization. As we have earlier seen, the goal of sentence tokenization is to identify the sentence boundary from the given text properly. And we all also know that the period symbol, which is a kind of dot, is not considered to be a sentence boundary all the time. Okay, let's take the sentence here. The text, that is Dr. Smith went to Washington dot on December 25th 2024, the event will occur dot, he said I'll be there dot, right. Now in this particular sentence, we could see Dr. dot and Washington dot, December dot and occur dot and there dot. As we see, there are 1, 2, 3, 4, 5 dots. Now all the 5 dots, are they sentence boundary or not? Actually they are not, right. So now the problem is how to identify which is a sentence boundary and which is not. Let's just implement as a code. Let's import the regex, regular expression. So we know that regular expression is a most powerful text processing tool. So this regular expression is used for searching, finding, substituting and matching the text, especially from the text, and use it exactly if you want to find and match, or substitute it with something else if you want to substitute it. So in this case, let's create a definition. So the task is sentence tokenization. Let's take the text and let's give a list of bag of words as a kind of abbreviations. So these abbreviations are the list of words which the program matches with the text, and if it matches, that means it should not be broken in that particular place, right. So now you have number of abbreviations, and now the task is now regex to split on period not preceded by an abbreviation. So the abbreviations that we have given should not be split. Now the sentences are now using regular expression regex split. We are splitting them using some kind of, like it can be of anything followed by any abbreviation and followed by any of the thing. It can be a to Z range, or it can be a smaller A to Z range, or it can be a number, and it can be a word boundary marker like space, right. So it can be of anything. So when you find this one, then return the sentence using the strip. That means the dot which is not there in the abbreviation should not be taken, but whereas the other thing should be taken, because now the splitting point for us is a dot. So now we have to again reintroduce the dot. Then let us just reiterate the whole thing until the end of the document. Now you could see, now we are giving the text, we are running the sentence with the definition that we have created, and we are printing it. Let me just run the code and show you how it exactly works. File. So when we are executing the file, now it's importing the regular expression, and as you could see, now the tokenization results you Dr. Smith went to Washington as one token. Is still doing it. Yeah. Now on December 25th 2024, the event will occur as a second token, and he said I'll be there as a third token. So now we are able to successfully identify the sentence boundary, because all periods are now not sentence boundaries. Once the sentence boundary is identified, how we can possibly do the word tokenization? A simple method I am going to show you here. Again, let's take the above text as it is, and we split that sentences into words or tokens. Now word tokenizer actually is been built again using the regular expression, because we have to match the word, and this pattern matches sequences of alphabetic characters and apostrophes, and they are also treating them as words, right. So now what we have to find out is between any of the boundaries, that means spaces, if you have any number of words followed by any number of abbreviations, and there is another space and followed by any of the other abbreviation in the text, then automatically you identify them as words. Now you could see, now we are actually giving the previous sentences as a list to the input of the word tokenizer. So now each of the sentences are being taken and it's been like pushed towards the word tokenizer. So now we are getting the output like line one by one. So now the sentence Dr. Smith went to Washington. Now doctor and dot I have split it here in this file like purposely, but if you want to put it again we need to have an abbreviation list. So if the dot is a part of the abbreviation list, let's not again split it from the doctor. That can also be done. And Smith went to Washington for the first sentence, that means each of them are actual separate tokens. Similarly, we are getting the second sentence on December dot 25, comma is a separate token, 2025 and again comma is a separate token, the event will occur dot again another tokens. Similarly, the other sentence. Now, this is a kind of pre-processing technique where we are trying to identify the sentences from the given text, and again from the sentences we are trying to identify words. Okay. Now, how we can do lowercasing? Lowercasing is also simple method using simple basic Python programming we can do the lowercasing. So, for the definition, lowercase is a function name which can be used from the Python for the given text. Now it will return you the text that is in the lowercase. Let us start with an example usage. Again, this is mixed case test where there are uppercase and lowercase text are being given. Now, what we have to do is lowercase the text using the function which we have built or which is already there, that is lowercase the text. Now, the printed function provides you the lowercase thing, that is this is mixed case text. So, this is a very useful technique for languages like English where we do not want to create more differences across the text where some letters or some words are written with capital and some words of the same type written in a small or a letter, then we can lowercase them to make sure that everything in similar order. And I was also talking about one of the other pre-processing technique that is called stop word removal. So, stop word removal is sometimes a very important task for certain application which we have already seen in the previous lecture. So, now to build the remove stop word as a function, what we need is again a text and again the stop word as a bag of words. Right. So, we have to define what are the stop words. So, stop words let us say is and it includes the, let us say these are the stop words. Then now we have to filter these stop words from the given text. Now, we have to iterate the word from the words that we get, iterate each of the word. If that particular word is not in the stop word list, then that is called a filtered word. Now, we can return the filter words. Now, let us say this is an example, text includes various tasks. Now, filter the text with all these things. Now, the final output you could see this example text it varies task, whereas is and it includes the, that is there in the actual text is being removed using the bag of word technique. So, now this can also be done not only by simple programming, there are other NLTK or SPACY kind of Python packages can be easily used where we can just call them and use it wherever required to tokenize sentences, words, normalizing and also stop word removing, lowercasing, all can be done using any kind of packages. Okay. Thank you.